Hello again, algebra students. We're going to spend another day solving systems of equations by graphing. So again, that means we're going to graph the two lines and find the one point, if possible, that makes both equations true. That'll be the solution. So it's the point of intersection of those two lines. Now, if I give you equations like we have here for this system, they're not in slope-intercept form. So I know that I would need to get slope-intercept form first. For the first one, I'm going to just try to squeeze it in between because it's a short process to get this one. I would want to get the y by itself, remember, which means I'm going to subtract this, and I'm even going to say a 1x instead of just an x. So that goes away, and I get that y equals negative 1x minus 3. Now remember, I can make my slope into a fraction. This means that my y-intercept is negative 3, right? That's what this tells me right here. So I'm going to start on the y-axis at negative 3. Then my slope is negative 1, which means down 1 and over 1. So I can also move up and left. So here's my first line. And again, the more points you graph, the more accurate your line will be. For the second equation, getting the y by itself is going to be a little bit longer process. So I would start by put a 1 in front of that x, and I would do a keep change so I can see the negative 4y. I would subtract 1x. So I have negative 4y equals, remember I always want the thing with the x first, and then minus 8. But I don't really want negative 4y. I just want y, so I would have to divide. If I divide there, I'm going to divide everything. Divide, divide, divide. So negative 1 over negative 4, same signs, is going to give you a positive 1/4. There's my x. And a negative 8 divided by negative 4 is positive 2. So that means I'm going to start at positive 2. And my slope is 1/4, which means up 1 and over 4. But then I run out of space and I'm moving away from that first line that I graphed. So let's move backwards then. Let's go down 1 and left 4. And that's going to hit right there. So my solution, the point of intersection, the one point that works for both lines, that ordered pair is negative 4, 1. Right? Make sure that you're getting the ordered pair. Slope, we go up and down first. Ordered pairs, we go sideways first. You could check this. If I put a negative 4 in for the x and a 1 in for the y, in my first equation, let me get rid of the stuff that I crossed out right there. This would be negative 4 plus the y was 1. Negative 4 plus 1, yep, that's negative 3. That works. In my second equation, I would have, I'm going to do this down here, negative 4 plus, now a negative 4 times 1 is going to be a negative 4. And when I add those two together, yep, that gives me negative 8. That one point is the only point that works for both equations. So that's the solution to the system. In this problem, again, I'll have to solve for y. I want you to notice before we start anything, how similar those two equations look. That's going to be really important as we get to graphing these. But let's take that first equation. I'm going to rewrite it over here so I've got some space. 4x minus 3y equals negative 3. So I would do a keep change, subtract the 4x. So I have negative 3y equals negative 4x, and then minus 3, or plus a negative 3 would be fine. And then we divide, divide, divide. So I'll get that y equals a negative over a negative is a positive 4/3. Remember, we don't want to change that. It's like 1 1/3 or a decimal. We like fractions even if they're improper. Plus negative 3 divided by negative 3 is positive 1. So this is going to start at 1, and that 4/3 slope means I'm going to go up 4 and over 3, or down 4 and over 3 to the left. And that looks like a positive slope, which it should. For my second equation, the work for this is going to look very similar. I would start, cube change, let's get rid of the 4x. So I have a negative 3y equals negative 4x minus or plus a negative 12. And then divide. Negative 4 over negative 3, again, that's going to be a positive 4/3 x, and negative 12 divided by negative 3 is going to be a positive 4. Before I graph this, I want you to notice the slopes. This has a slope of 4/3. This has a slope of 4/3. And we know that if lines have the same slope, they're parallel. Now, when I graph this, I'm going to start at positive 4. I don't have space to go up 4 and over 3. So I'll move down 4 and left 3. And in fact, that's all I could really fit on here. I could move down 4 and then left 3 would be over here a little bit. Those two lines are parallel, which means they will never cross. Now, we didn't see this the first day. However, remember, the only solution is the point that makes both lines work. It's got to work for both equations. And there is no point that's going to work for both of these. Every single point on the red line, every single point on the black line, every single point is a solution for that equation. But there is no point that's shared. There's no common intersection point here. So this has no solution for my system. So occasionally that does happen. If you've got parallel lines, they never cross. And remember the point that they cross at, that's what we're looking for. That's our solution. Okay, in this problem, we again need to get the y by itself. So let me rewrite this top equation over here a little bit. So negative 6x minus 2y equals negative 8. And we would do a keep change. Let's get rid of the 6x. So I'll have negative 2y equals 6x plus a negative 8. And then divide. 6 divided by negative 2 is negative 3. There's my x. Negative 8 divided by negative 2 is positive. Once again, I'm sorry for the bell. That starts at 4. My slope is really a negative 3, or negative 3 over 1. Remember, this has to go downhill. So down 3, right 1. There isn't room for me to go up 3 and left 1. But there's my line. Now, for my second equation, I'm going to subtract the 3x. And I get that y equals negative 3x plus 4, which is interesting because it's exactly the same line. If I would graph this line, it would go right on top of that green line. They're the same line. Now remember, every single point that was on that first line that I graphed is a solution for that equation. Every single line for the second, or every single point for that second line that I'm going to graph, I'm going to do my best to try to match it up well here. Also a solution for that equation. Now, we've talked about this. We said that the solution for the system is the point that they have in common. Well, in this case, it's points. Every single point that's on the first line is also on the second line. Now, if this was just a regular equation that we were solving originally, we would do something like this and say, any real number. Well, these aren't just numbers. We need points. We need every single point on that line. The way that we're going to write this is all points on the line. Now, every year I have some students that say, well, can we say APOTL? You know what? In class, I don't really care. Please do not give an answer of APOTL. It's got to be all points on the line. But every point that's on the first line is also on the second line. So every single point is a solution for this system because these two were exactly the same equation. And you can see that if you would multiply everything by, in the second equation, if I would multiply everything here by a negative 2, I would get exactly that top equation. So again, typically we get one ordered pair. Sometimes we get parallel lines, so there's no solutions. And then sometimes we get all points on the line. This one I can tell will not be either of those different kind of answers. By looking at these two equations, I can see they're not going to have the same slopes. They're not going to be just a multiple of one of the equations to make the other equation. These are totally different equations. So if I would, on the top equation, just get rid of my 3x, I would have that y equals negative 3x minus 4, or plus a negative 4, which means I would start at negative 4, and then typically I would go down 3 over 1, but I don't have space, so I have to go up 3 and left 1. So there is my first line. And then the second line, we have to be a little careful on this one. I would do a keep, change, and I'd sneak a 1 in front of that y. So when I subtract this 2x, I'll have negative 1y equals negative 2x minus 1, or plus a negative 1. But I don't want negative 1y, I just want y. So we have to divide, divide, divide. So negative 2 divided by negative 1 is going to be positive 2 with the x, and then negative 1 divided by negative 1 is positive 1. So we start at 1. My slope is, I'm so sorry about those bells, everybody. My slope is 2 over 1. So again, this is the typical kind of situation that we get. The ordered pair for where these two lines cross is at negative 1, negative 1. And you could substitute that back in to make sure that it works. So today's worksheet is solving systems to the second day of solving systems by graphing. The answer keys in Schoology. And then when you're done with that and you check it, make sure that you take the formative in Schoology and let me know if you need any help.